what we will do today is discuss some important concepts of wave optics. In few of the JEE Mains questions, you will see the words like geometrical spread and diffraction spread. Okay, so how do you solve these questions, and what is the difference between the geometrical spread and the spread caused by the diffraction? Okay, so let's start with the geometrical spread first. Okay, and the simplest, most geometrical spread, what you see on the screen is being described. So essentially what it means is that if you have a situation where the geometrical spread is because of pure geometrical considerations. Okay, for example, in Young double slit experiment, the spread, which is basically the fringe width, let us put this way, is decided by what? It is decided by the slit separation, the screen distance, which are all geometric factors, right? So if you're talking about a geometric spread in the context of Young double slit experiment, what you're referring to is the fringe width. So if you get a question in JEE Mains where they tell you that geometrical spread is due to the Young double slit experiment, they are referring to the fringe width. Now the problem is that the concept is simple. The formula of fringe width is very simple. What is difficult is what is the meaning of the word geometrical spread. Simply speaking, in the context of YDSE and only YDSE, it means that the fringe width is being referred to because that is the only thing which depends on geometry of the experiment. The slit separation, the screen distance are all geometric factors. So I hope the concept of geometric spread is now known to you. If you get this question, please don't panic. Please continue to solve it very simply, referring to the fringe width if it's a question on the topic of Young double slit experiment. Let's go to the next one. Okay, now if you talk about the next one, okay, I will come to the one which is another one. Okay, the second type of geometrical spread you will see in these questions is also a very interesting geometrical spread. Now, this is the geometrical spread which is due to the wave, not wave effect, but the geometrical optics. What does it mean? So, for example, if you have a hole, which is a slit, and you pass light waves through that, as per the geometrical optics, no diffraction type of impact, which is spreading, will happen, right? The geometrical spread being referred to here is basically a creation of a spot directly in line with the slit. You have a slit of aperture 2 millimeters. You send a light source through that. What you will notice on the screen is a spot of 2 millimeter diameter. Why? Because the aperture is sending the light waves straight, right? It's like a ray. In fact, it's not a wave. It's a wave when you talk about Young double slit experiment. It's a ray of light which is going and striking the surface of the screen and resulting in formation of a spot. So such a geometrical spread is because of the ray optics. This assumes that there is no diffraction, right? Generally we take diffraction. That spread is different. That's a third spread. So geometrical spread by virtue of wavefront geometry is very simple. It pertains to a situation where the spot is formed directly opposite on the screen in line with the slit. That is what is the geometrical spread. Very, very simple, right? So it's all about ray optics. It has nothing to do with wave optics. So this was geometrical spread number 2. And then, of course, in JEE Mains and NEET examination and board examination, what you will see is another type of spread, which is called the diffraction spread. I think the diffraction spread is very well understood, but let's go back and study this also, okay? So if you have a spread like diffraction, then they're referring to the bending of waves, okay? Now, through a very small aperture, right? This is the basic, right? And you know that diffraction can be explained with the help of Huygens principle. That is well understood. Now, the spread of diffraction refers to basically the spread of the central diffraction maxima. Okay, like in case of YDSE, the geometric spread refer to the fringe width. In the case of the diffraction, it refers to basically, essentially, although you have many secondary wavelets and other fringes also formed, but primarily it refers to the central bright fringe of the diffraction, which is created on both the sides, right? So the total width of the diffraction pattern is the width of the central bright fringe, which is on the upper side and the lower side. I hope this is making sense to you. The central maxima, the central width, on one side is lambda by A, right? If you double this, where A is the width of the aperture through which the diffraction happens. So the total width of the diffraction pattern is 2 lambda by A. So there are three types of, the spreads you will see in wave optics. One is the pure geometrical spread in line with the direction of the ray. The second is, of course, the geometric spread because of YDSE, which is nothing but the fringe width. And the third type of spread is because of diffraction, which is bending of light primarily. And that too, in the width sense, refers to the width of the central maxima of the diffraction pattern. And also remember that the central maxima of the diffraction pattern includes a lot of geometric spreads caused by the YDSE, if it's a YDSE. So in a YDSE experiment, you see both the geometric spread caused by the YDSE. Obviously, it's a YDSE, so you must have the fringes being created because of YDSE. And then, of course, you will have a central maxima also, which is due to the diffraction pattern. So the diffraction pattern will include a lot of interference fringes also within them. And therefore, we say that spread due to diffraction includes the spread due to the YDSE. In fact, many spreads of YDSE, because many wave fringe widths of YDSE have to get together to create, to get inside the envelope of the diffraction. Okay. I hope this is making sense. Three types of spreads are being emphasized. Okay, let's do a quick revision. Okay, now if you see, what is the key difference between the spread of YDSE and the spread due to diffraction? So YDSE is a purely geometrical thing, right? In the sense that it only depends on screen distance, slit width, and separation, and geometrical factors of the experiment. But the diffraction, which is the bending of light, depends on the wavelength and the slit width, not on slit separation, obviously, right? And this is much wider because we're referring to the central one, right? So and what is the impact of the pattern? The effect on pattern is that the geometrical spread is essentially measured with the help of the fringe spacing, but in the case of the diffraction, it is basically the 2 lambda L by A, which is the width of the central maxima of the diffraction, right? So and of course the spread due to diffraction is because of the wave nature of light. Okay, whereas the width of the fringe is definitely, YDSE is created because of wave nature of light, but YDSE fringe width is purely dependent on the geometrical factors, hence the name geometrical spread also in the case of YDSE, which refers to the fringe width. Okay, so I hope this is a good concept you learned today. When you solve questions and you come across the word geometrical spread, please don't panic. It can be as simple as a point spot getting created as per the size of the aperture. That is one. Second, it is a fringe which is being created due to the YDSE experiment, which also is a geometrical spread. And third is the diffraction spread, which you already understand is because of the wave nature of light. So I hope you enjoyed this video. Please subscribe to this channel and spread it to as many students as you can in your community. And don't forget to join my community tab, where I have given around 1200 questions so far, all highly conceptual. It will help you score very well in your JEE examination. I have also announced a test of JEE Main's mock test, which will happen very soon. Please follow my post and do appear for the test. It will give you an insight into how well are you prepared for JEE Mains. Okay, it's a 90-minute test, and look forward to see you there. Thank you very much.